friends, in today's class we shall discuss about equation of a plane passing through three non-collinear points. What is the equation of a plane that is passing through three non-collinear points? Here in this figure, the points are S and T, these three non-collinear points. Let R, S and T be three non-collinear points on the plane with position vectors vector A, vector B and vector C respectively. The position vector of point R with respect to the origin, that is vector A, the point S with respect to the origin, it is vector B, the point T with respect to the origin, that is vector C. The vectors Rs and Rt, the vectors Rs and Rt are in the given plane. Therefore, the vectors Rs vector cross Rt vector, this vector is perpendicular to the plane containing the points R, S and T respectively. And let R vector be the position vector of the point P with respect to the origin in the plane. The equation of a plane through R is perpendicular to the vector Rs vector cross Rt vector is Rp is perpendicular to the vector Rs cross Rt, that is Rp vector dot Rs vector cross Rt vector equals 0. Rp vector is perpendicular to the vector Rs vector cross Rt vector. That means Rp vector dot Rs vector cross Rt equal to 0. Rp vector can be written as OP minus OR dot Rs vector can be written as OS minus OR cross Rt vector can be written as OT minus OR equal to 0. OP is that is small r vector minus OR is A vector dot OS is vector B minus OR is vector A cross OT is vector C minus OR is vector A equal to 0. So which is the vector form of equation of a plane. The next Cartesian equation of a plane. What is the Cartesian form of equation? The next Cartesian form of equation of a plane. So let x1 comma y1 comma z1 comma x2 y2 z2 and x3 y3 z3 be the coordinates of the point R, S and T respectively, and let x comma y comma z be the coordinates of the point P with position vector A on the plane. Then A vector is equal to x1 high, or A vector, that is Rp vector. Then Rp vector is equal to OP minus OR, that is Rp vector is equal to OP xi plus yj plus zk minus OR x1 high plus y1 j plus z1 k. So therefore Rp vector is equal to x minus x1 high plus y minus y1 j plus z minus z1 k. This is Rp vector. The next Rs vector OS minus OR, it is Rs vector OS x2 high plus y2j plus z2k minus x1 high plus y1j plus z1k. Therefore Rs vector is equal to x2 minus x1 high plus y2 minus y1j plus z2 minus z1k. So Rs and Rt vector equals Ot vector minus OR. Therefore Rt vector is equal to Ot, that is x3 high plus y3j plus z3k minus x1 high plus y1j plus z1k. Therefore Rt vector is equal to x3 minus x1 high plus y3 minus y1 j plus Z3 minus Z1 K. So now substituting these values in vector form of equation of the plane and expressing in the form of a determinant. So now Cartesian form. Cartesian form. It is in vector form of equation or vector minus a vector dot vector b minus vector a cross product vector c minus vector a equal to 0. So therefore R minus A can be written as RP vector dot RS vector cross RT vector is equal to 0. Now by using the definition of scalar triple product, this can be written as in determinant form. So R1 RP is determinant form x minus x1 y minus y1 z minus z1. The next RS vectors are x2 minus x1 y2 minus y1 z2 minus z1. Or t vectors right in third row x3 minus x1 y3 minus y1 z3 minus z1 equal to 0. So this is the Cartesian form of equation of a plane passing through three non-collinear points. Now we shall do the problems, or we shall take the examples. Now example 1, find the vector equation of the plane passing through the points R 2 5 minus 3 comma yes minus 2 minus 3 5 and t 5, 3 minus 3. Find the vector equation of the plane passing through the points R, S and T. Here let R point, that is 2, 5 minus 3 implies OR vector, that is equal to vector A 2i plus 5j minus 3k. S point minus 2 minus 3 5 implies OS, that is equal to vector B minus 2i minus 3j plus 5k. T 5 3 minus 3, this implies OT vector is equal to vector C 5i plus 3j minus 3k. Now write vector form of equation. Vector form of equation of a plane. Vector form of equation of a plane is vector R minus vector A dot vector B minus vector A cross vector C minus vector A equals 0. Vector R write as it is minus A vector 2i plus 5j minus 3k dot B minus A vector minus 2 minus 4i minus 3 minus 5 minus 8j 5 plus 3 plus 8k. So vector B vector minus A vector cross C minus A 5 minus 2 3i 3 minus 5 minus 2j minus 3 plus 3 gets cancellation 0k. So which is the vector form of equation of a plane equal to 0. Then one more example. Now example 2, find the vector equation of the plane passing through the points R 1, 1, minus 1, S 6, 4, minus 5 and T minus 4, minus 2, 3. Here also let or 1 1 minus 1. This implies OR vector is equal to vector A I plus J minus K. S 0.64 minus 5. This implies OS vector is equal to vector B 6I plus 4J minus 5K. T point minus 4 minus 2 3. This implies OT vector is equal to vector C minus 4I minus 2J plus 3K. Now vector form of equation of plane. Vector form of equation of a plane is given by vector R minus vector A dot vector B minus vector A cross vector C minus vector A equals 0. Vector R write as it is minus vector A I plus J minus K dot vector B minus vector A 6 minus 1 5I 4 minus 1 plus 3J minus 5 plus 1 minus 4K. So vector B minus vector A cross product C minus A minus 4 minus I minus 5I minus 2 minus 1 minus 3J plus 3 plus 1 plus 4K is equal to 0. So vector equation of the plane. The next example 3, find the Cartesian form of equation of a plane passing through the points are 1, 1, 0, yes, 1, 2, 1 and t minus 2 plus 2 minus 1. So using these 3 points, non-collinear point, find the Cartesian form of equation of plane. Here let R 1, 1, 0, that is x1, y1, z1, yes, 1, 2, 1, so x2, y2, z2, t minus 2 plus 2 minus 1 is x3, y3, z3. Now Cartesian form of equation 1 by, that is determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. This implies determinant of x minus x1, x minus 1, y minus y1, that is y minus 1, z minus z1 is 0. x2 minus x1, 1 minus 1, 0, 2 minus 1, 1, 1 minus 0, 1. x3 minus x1, minus 2 minus 1, minus 3, 2 minus 1, 1, minus 1, 0, minus 1 equal to 0. Now expanding this determinant, x minus 1 into minus 1 minus 1 minus 2 minus of y minus 1, 0 plus 3, 0 plus 3 plus z into 0 plus 3 equal to 0. So therefore minus 2x plus 2 minus 3y plus 3 plus 3z equal to 0. Therefore minus 2x minus 3y plus 3z plus 5 equal to 0. Therefore plus 2x plus 3y minus 3z minus 5 are equals plus 5. So which is the Cartesian form of equation of a plane. Okay students, stop here. So we'll continue in next class.